Oh, is there a typo? Problem?
Power is what?
Should be. Did I write something else?
You asked about the power and the answer was confused.
Disgraceful. I hope the number was at least right.
I don't know.
Okay. Hopefully it's just a typing mistake on the unit. Okay. Alright guys. We'll continue now. Continue. We will continue. We have 2 hours, don't we? Yeah, okay. I thought it was 2 hours. Right. Next lesson. Conservation. Oh, for goodness sake, that's not how you spell conservation. I-O-N. I-O-N. Conservation of momentum. Got that? Yeah. Let me just fix that typo. Alright. Right, so, collisions. A special type of collisions in physics is that which is between two masses. So a lot of what we'll do now today is looking at two masses colliding. And also that there's no external force. So the two masses are moving along and just collide. And they don't collide because maybe this would be an external force. If I grab this and then start doing this. That's a collision, but not the one I want to study today. I want to look at ones that just they're moving by themselves and they collide, not because there's an external force making them collide. So this is a special type of problem in physics. A good example is what I have in the picture. This snooker ball rolls and hits another snooker ball, and there's no external force. Now you might be thinking, no, there is an external force because the person hits it. But we don't care about how the ball began moving. We just care about looking at the picture around the time of the collision. Was there any force around the collision time? No. The force happened too long in the past to care about. So there's no external force here. Now in real life there is an external force. There's the friction on the table, but we'll ignore that as being quite small here. So what exactly is conservation of momentum? Well, we know momentum. What's the formula for momentum? mv. And what's the word conservation? I think we had this already. Yeah, of course we did. Conservation of energy. Not created or destroyed. Not changing. So, conservation of momentum, you could probably guess the meaning. The conservation of momentum says during a collision between masses in a closed system, the momentum will be conserved. Mathematically, as a formula, you have something that you might have seen before. It says m1u1, that's the momentum at the beginning of the first one, plus m2u2, the momentum at the beginning of the other one, equals m1v1, the momentum afterwards of the first one, plus m2v2, the momentum afterwards of the second one. In other words, total momentum is the same before and after collision. Obviously, m1 is the first, m2 is the second, u1, and so on, so on. You don't have to write all that down, it's, I think, obvious. But you do need this formula and its definition, conservation of momentum. You have a choice. You can write a sentence or the formula. However, if you do write the formula, you must say what each term in the formula represents. So your choice is to either write this, your choice is to write this or this and this. Now, this is easy to remember, but a lot to write. This is not much to write, but harder to remember. So it's a balance, whichever you prefer. Yeah. That is okay. Did you write the name down? Yeah, but write it down again beside the formula. It'll help you remember it. Okay, continue? Yeah? What's that? Yes, no? Yes, continue? Okay. So, roughly speaking, there's actually two types of collisions that we're interested in looking at. And the two types, well, let me see, does anyone know the two types of collisions? Elastic and inelastic. So, they're called elastic. What's an elastic collision then, if you know? Yeah? Here? Oh, give me some more words than this, please. Okay. So the shape changes. No, let's not say this. The shape stays the same. So what else could it be? And the mass is the same. Anyone? Ah, no, not this. Getting closer. Yeah. It does have to do with whether they connect or they separate. That's one way to define it. But more technically, the definition is this. It's an elastic collision if no kinetic energy was lost. And we say it's an inelastic collision if we have a loss of kinetic energy. Now, you might say, but Stephen, you said energy isn't lost. Well, yeah, but I'm not really meaning lost here. What I mean is kinetic energy maybe transfers into heat or something like this. So elastic means no loss of kinetic energy, and inelastic means some loss of kinetic energy during the collision. Now, you were actually saying about the separating or not. It actually is related to this, whether they connect or they don't affects the kinetic energy. But for the exam, the definition is this, whether there's a change or not in kinetic energy. Yeah. No, I'll continue, yeah.
What kind of form?
What do you mean?
Other forms.
Yeah, so what happens is in the first one, no kinetic energy is lost. I think that usually means the two of them collide and then separate. In the second one, inelastic, if the two of them collide and then stick together, this actually usually results in a loss of kinetic energy. So the kinetic energy before they collide and then after they collide is different if they stick together. It's like the sticking together causes some loss in kinetic energy. Whereas if they just went like this, the kinetic energy shouldn't really change. Now there's other ways to lose kinetic energy. For example, if the material is a little bit not so bouncy, you know, if it's not so rubbery. Like for example, if I drop this, or well, if I throw this against here, this probably will be going slower after the collision because of the material. So what happens to the kinetic energy of this? Well, it's less, because before it was going fast and then afterwards it's going slow. So there are many ways to lose kinetic energy. Most collisions are inelastic naturally. Elastic collisions don't, they're not 100% possible. Yeah. It's a bit like the efficiency. The efficiency is never quite 100%. Okay. Come on, there we go. Right, so let's have a look at our first example. A 1 kilogram trolley is rolling towards a 2 kilogram trolley at a speed of 3. So let me just draw that for you. So you have a little trolley car, and it's 1 kilogram. And there's another trolley here, and it is 2 kilograms, I think I said, was it? Yeah. And this one's moving along at 3 meters per second, and this one is at 0 meters per second. When they collide, they stick together. So, this one here, this one here, and then after the collision, they're like this. And if you want, you can actually think about this as one trolley of 3 kilograms with a speed, we don't know, I'll call it V. So this is the picture at the beginning, and this is the picture after the collision. Right, so let's do this together. The first one, what is the V? How to get the V? Okay, so what rule should I use to get the V here after they collide? Well, the conservation of momentum. Yes? So let's try and write this down together. Okay, what's M1?
1.
U1? 3. Plus M2?
2.
U2?
0.
0. Now, before I continue, do you want to think of this as 2 trolleys or 1 trolley?
Sure.
Okay, so then we only have one thing here,
Yeah.
M1, V1. So what's M1? 3. And V1? 3. Right, so we get 3 equals 3V. So V is 1 meter per second. So before the collision it was going at 3, and afterwards they're both going at 1. Okay, that's okay? That makes sense? We're happy with this? So that's part A. Part B. What is the kinetic energy before the collision? Okay, so KE1, that would be a half mv squared plus a half mv squared, which is 4.5 joules. Okay, what do you think my next question is going to be? If I ask you the kinetic energy before the collision, the next thing I might ask you is after the collision. Kinetic energy after the collision is a half mv squared, which in this case is 1.5 joules. Okay, D, I'm probably going to ask you if there was a loss. Yeah, what type of collision is this? This is inelastic because, yeah, the change in kinetic energy is minus 3 joules. It lost 3 joules, so we call it inelastic. Yeah, we're okay with that? E. What is the impulse on each trolley? So this is a sort of a question from a previous lesson to see if you remember. What is the formula for impulse? Yeah, impulse. Yes? Correct, it is. There's another formula for it though that we can use. I won't use that one because I don't know the force of the time here, but there is another formula. Get ooh, close. You have half of it. The change in MV. So it's actually MV minus MU. So for trolley 1, it will be M1V1 minus, M1V1 minus M1U1. What's the M here? It's, for trolley 1 it's 1. And the V1 is 3 minus 1.
Yes.
No. 1 minus 3. Isn't it?
Oh, no.
V is 1, U is 3 for the first one. So this is minus 2 kilogram meters per second. Okay, what's the impulse of the second trolley? At V2 minus M2 U2. Yes. Which is 2, 1 minus 0. Which is 2 kilogram meters per second. Now the reason I asked you to do this is you should notice something interesting between the two results. The same but different direction, yeah. In fact, in some way this is like Newton's third law, that the impulse on one is equal and opposite to on two. In other words, there's an action, a reaction, an action and an opposite reaction. I just wanted to do this one to show you that it's not actually an accident. This should always happen for these problems. That the impulse change on one should be equal and opposite the impulse change on two. That there's this relationship between them. Okay. Why is the impulse on one negative? Well, if you think about it, one is going at 3 and now it's going at 1. So there was some kind of force acting to its left. Why is the impulse on 2 positive? Well, first it was at rest and now it's going at 1. So there was some kind of force acting to its right. Yeah, the impulse here, guys, if you forgot, is the change in momentum, delta P. Okay, continue. Yeah. Right. I think I just have the one more, but it's a hard one. A 2 kilogram mass heading right at a speed of 4 collides with a 2 kilogram mass heading left at a speed of 2. As a result of the collision, half the kinetic energy is lost. What is their speed after the collision? I'm going to do this one because it's a bit tricky, but I'll just draw it first. So 2 kilogram heads right and a 2 kilogram heads left. Two kilogram heads right, 2 kilogram heads left. This one's going at 4, this one's going at minus 4. Yeah. No. Yeah. Oh, they're not both 4. Sorry, the other one is a 2. After the collision, now I don't actually tell you if they stick together or not, do I? They might stick together, they might not. Yeah, they might stick together or they might not. I don't tell you. You don't actually need to know, because what we'll do is we'll say this is a 2 and this is a 2, and this one afterwards we'll call it a V1 and a V2. Now I kind of know they won't stick together. They should move like this. But I could know if they stick together, because if my V1 answer equals my V2 answer, then they must have stuck together, because it means they're moving at the same speed, so they're kind of stuck together then. But I don't really need to know if they're stuck together or not. In fact, maybe I'll tell you that they don't stick together. Yeah, what are their speeds after the collision? So we'll say they each have a different speed. They do actually each have a different speed. Okay, so let's see what equation we can make. Conservation momentum, what does that say? So what will I write? What number first? M1, so what have I got? 2, 5, 4, plus, yeah, minus 2, very good, equals,
2.
yeah, good. 8 minus 4 is 4. Divided by 2's is 2. Now, why is this a problem? Well, I don't have enough, do I? I can't know, yeah? That's it. There's another equation we can make. I say half the kinetic energy is lost. This can be used to form another equation. But what equation can I make? Well, let's say the kinetic energy here is KE1 and here is KE2. What equation can I make from these if I tell you half is lost? Well, which is bigger? By how much? Twice. Double, yeah. So in other words, KE1 should be double KE2. Because if half of it's lost, then this number is twice as big as this number. Or, if you prefer, you can say KE2 is half the value of KE1. Both will give you the same result. But I don't want fractions, so I'll keep it like this. Okay, KE1, what's that? A half, 2, which is 16, yeah. 4, yeah. Equals 2, etc., etc., yes. A half 2 V1 squared plus a half 2 V2 squared. Now that's nice because they cancel, they cancel, they cancel, they cancel. 16 plus 4, 20 divided by 2, 10. So V1 squared plus V2 squared equals 10. Do we? Where do we know V1 multiply V2? Huh? I'm very confused by what you're telling me. What are you telling me? Is it a good thing? Oh, no, don't be shy. I'm a friendly teacher. What's wrong? Okay, don't tell me. That's okay. Yeah, you've done these in maths class? These problems in maths? That's it, yeah. You can say V1 equals 2 minus V2 from this and put that in here. So you get 2 minus V2 squared. Oh, and before I continue, I should say that I expect V1 to be negative and V2 to be positive. So I'll just say that before continuing. Right, that plus that equals that. 4 minus 2V2 plus V2 squared plus V2 squared equals 10. 2V2 squared minus 2V2 minus 16 equals 0. V2 squared minus V2 minus 8 equals 0. Right? Huh? Oh, it's not minus 16, I'm sorry. It's 6, isn't it? So this should be a 3. Okay, so 3 and 1? 3 and 1. V2 minus 3 and V2 plus 1 equals what? That's right, isn't it? Huh?
That's true.
It's not true. It's not this.
Yeah.
Oh, of course it's not. Sorry, apologize. Sorry. Do we have to use the formula? Do we? We do. Right, well, before I do that, is my V2 answer I want positive or negative? If we look back at the picture. Positive. So I won't bother with the negative answer, I'll just go straight into getting the positive answer. So V2 equals minus B plus square root B squared minus 4AC all over. The V2 is a plus.
Minus 1 minus the first one.
Yes. Yes it is, thank you. All over 2. So my answer is 1 plus root 13 over 2. Whatever that is. Whatever it is. And then how can I easily get V1?
2 minus.
Yeah. 2 minus that. So it'll be 2 minus this answer. And I'm sure that will be negative when you calculate it. Let's see. 4 over 2. Is that 3 minus root 13 over 2, I think. So these are my two velocities. Yeah? Give me a question.
The top part.
Which part?
Below the 2 equals D1.
Higher or lower?
Higher. Yeah.
Yeah? Oh, this one?
Yeah.
Where did I get it? From here.
I don't understand.
How did I get this one? I got it from here. And how did I get that one? I said in the question that half the kinetic energy is lost. Half the kinetic energy is lost. So for example, if the kinetic energy here was 10 joules, then here it should be 5 joules. If the kinetic energy here is KE1, then this one should be a half KE1. In other words, this number here should be twice as big as this number. That's how I can make that. What's positive? That number's positive? No, I don't believe you. Give me. Oh, it is. That's quite interesting, isn't it? What went wrong here?
But there should be negative.
Oh, I know it. I know it should be. It means I wrote one of the numbers down wrong. Which one though? Which one? 2 minus 2, 4 minus 10. Don't you worry, I'll figure it out. Wait, huh? No, they told me it's not. Dude! I just typed it in there. It is negative. Look!
You put the theory.
Oh, instead of 13. Now, I should say, although this is quite hard, I've actually seen this question in the exam twice. So, this is the hardest it could be in the exam, and I have seen questions like this in the exam.
Like this?
Like this, yeah. Yeah.
Final exam?
Yes. The tricky part, I think, is this part. I would hope solving these is not a tricky thing. Maybe you've even done it in maths class already. Have you done this lesson in maths class, the one linear and one quadratic?
Yeah.
That's all this problem is. Okay, have you got this written down now?
In kinetic energy direction does not matter.
It does not, because you're squaring the v always, so the sign disappears. So kinetic energy is not like momentum. You can actually drop the sign if you want. Yeah. I mean, if it makes you happy, you can put in the negative, but it's not of importance.
Then, why do you say that V2 is positive and V1 is negative?
Because they're not, the v's are velocities, not speeds. And I'm saying one is negative and one is positive because I know afterwards they'll be going in opposite directions. And it can't be the other way around because they can't swap places. Because they're velocities, I need to know which way they're going. Also, it's because when I get to this line, I'll have two answers for V2. I need to know which one to choose. I should choose the positive one because if I choose the negative one, it means it's passed through its friend and gone on the other side. So I do need to think about the signs and I do need to choose the right one. So it is useful to write at the beginning what I expect each one to be, a positive or a negative.
What if it moves together in the same direction?
I don't know if this is possible. If you're not sure of the direction, so in other words, if you discard this information here and then look at both answers, this is what would happen. You would get one answer which is a positive and a negative, a negative and a positive, like what I just got here. But then when you look at the other answer in the quadratic, then you'll actually get a positive and a negative. And you kind of have to reject this. Now, if you got something like a positive and a positive, then I would think the other answer would perhaps be a negative and a negative. Or maybe there might not. I don't know actually. I don't know if it's one of these things where, because the kinetic energy was lost, it's impossible for them to move together at the same speed. I don't know. Anyways, to give you a short answer, if you get positive, then they've moved off together, or negative, they've moved off together. But here, when I look at my first answer for V2, if it's a positive, and when I put it into this, I'll get the V1 will be a negative. But if I look at the negative answer here, and put it into this, then the other one will be a positive. So it's quite clear that they're moving in opposite directions. I just need to choose the one that makes sense. It makes sense that this is positive and this is negative, because if I choose the other one, it means this is hopped and hopped true. You know. Continue. Yeah. Yeah. Okay. I should actually say also, in the question I asked for the, who's waiting outside? That's not one of the temperature, is it? Is that Monica one? Is it Monica? Monica? Is it just you outside? Okay. Want to come in? I'm going to finish now. Wait, I should say, I actually asked them the question for the speeds, so don't worry about the signs in the final answer. Anything else? Yes? Yeah. It is. Awkward. Guys! I made a mistake. Here! This should have been a 4.
Yeah.
No, don't pretend you knew all along. Okay, don't do that, please. So that should have been a 4, which means this should have been a 4, which means this should have been a 2. Much easier now. This will be V2, what I originally thought, V2 minus 3 and V2 plus 1. Which answer do we want to take? The positive answer, which is 3. That's for V2. And the other answer for V1 would be minus 1, yeah. Thank you. One student is awake. The problem, you see, is I have very bad coffee this morning. It's not doing it. Don't shake your head over there, Monica. It's not doing anything for me. Harsh. You're so harsh to me. What have I ever done to you guys now? Alright. Write this down and then we'll finish. If you can try those questions for homework. And then tomorrow we'll have the tutorial. We'll have a look at any problems from the last lesson. And don't forget, you need to bring something that has internet access, because we'll talk about the assessment support after lunchtime. Yeah? You can bring your laptop if you want. Yeah, there's 2. But I'm choosing the one that has the right direction. I need the V2 must be positive and the V1 must be negative after the collision. So although there's 2 answers here, I reject this answer. Yes? Stop the video? Close this? Okay.